Okay, on this one I'm going to demonstrate the special products and how to factor them. Um, the difference of squares and the difference in sum of cubes will always be binomial. And these other ones that are trinomial, technically you could use trinomial factoring. It's just when you have ones like example B here, it will take you a whole lot of time. So it's best if you can recognize that there is a special case going on that involves squares or cubes. So the first one, I recognize that this right here is b squared, and I recognize this is 8 squared. So I ask myself, if this was b plus 8 to the second power, if I multiply these together and double it, is this the middle term? Because the rule was I put an X here. Okay, I know that doesn't look exactly like the rule, but it said first term squared, last term squared, and these are the square roots multiplied together with and doubled. So this is the special case, okay? Let me scratch out of the way so it doesn't get you too bad confused. Just think, is this a perfect square? Is this a perfect square? And if it is, by George, if we can multiply those square roots together and double it, hopefully it comes up to this. Then you know it's the special case. It's the square of a binomial. Okay, I'm hoping this is, but when I look at this, I don't see something squared. But I do see I could divide 5 out of all this. And when I do divide 5 out of all of it, I'm going to change colors here so that you can, so you'll realize there's a problem inside a problem here. If I divide this by 5 and b, I guess I better divide a b out using GCF factoring, I'm going to end up with 9x squared minus 6x plus 1. And this is a perfect square. This is a perfect square. And so now I need to ask myself, if I do the square root of these and I get, I'm going to just come over to the side, I would have 3x plus 1, or actually I need to put a minus because of this here. If I multiply them together and double, do I get this? And the answer is yes. So I can rewrite this whole thing as 5b times 3x minus 1 squared. Okay? I know it's kind of a stretch when you look at this to think that you're going to be dealing with one of these special products, but you know, always do the first things first. The first thing you're going to do is GCF factoring, and when you do GCF factoring, a lot of times it opens doors for you. Okay, the next one is a difference of squares, and you just rewrite it as a conjugate of the square roots. And so the square root of x squared is x, square root of 16 is 4. I'm going to put minus 4 in the first one and plus 4 in the second one. It doesn't matter which one you put in which. Same thing on the next problem here. This is 5b squared, and this is 7 squared. So I'm going to do conjugates with square roots here. 5b and 7, and then 5b plus 7. That's it. I've got a couple more binomials here. This one doesn't look like squares, but once again, like I said, if you'll do first things first and do GCF factoring if you can, we can divide 5 out. That gives me 9 minus 4x squared. This is definitely a difference of squares, so when I rewrite it, let's see if we can do it without a lot of fanfare here. Square root of 9 is 3. Square root of this is 2x. And that's it. Really, difference of squares are the easiest ones you can do. The next one is a sum of cubes. And if you remember the picture I drew earlier, that's good proper English, in the previous video, You have to do the cubed root of x to the third, which is x. You know, what did we raise the third power to get? X to the third. What did we raise the third power to get? 64. Well, it's probably not obvious, but the answer is going to be 4. 4 times 4 is 16 times 4 is 64. Now, from this, we can ignore this now. From this, I'm going to do what the picture said. Square, square, and then I'm going to multiply these two things together and change the sign. And that's it. So on these special binomials, the cubes are the harder ones, but they're not impossible. Sometimes I feel like maybe we're doing too many examples, but anyway, I'm going to keep on going. This is a sum of cubes. What did you cube to get a to the third? It's a. What do you cube to get 8b to the third? It's 2b. 2 times 2 times 2 is 8. Now, I ignore this. I'm just going to square, square. I went ahead and did 2 squared. And then I'm going to multiply these together and change the sign. So that's going to give me a negative 2ab. This right here is a difference of cubes, but it's still the same rule. I think what would I have to cube to get 27? It's 3. What would I have to cube to get negative y to the third? A minus y. And I'm just going to ignore this. I'm going to cube. No, I'm going to square. Sorry. Square, square, which would become positive. And then I'm going to multiply these together and change the sign. So that will give me a positive 3y, and that's it. That's all the examples I have. Good luck on the homework. I will try to put some examples of that up also. Factoring is such an important thing. I felt it was kind of important to give you extra help and extra information on it. Please make sure you do all the homework on factoring, considering it's such an important topic later on.